Assalamualaikum and good day. Welcome to Secretary Kim's group, Introduction to Experimentation. The experiment that we will be conducting today is a titration of NaOH solution against aspirin. Now before we begin, I would like to introduce to our group members. The first is me, Irdina binti Azri A20SC0439, followed by Sahizan Zaihan bin Ismail A20SC0350, Aisyah bin Mashure A20SC0015, Tan Sinjo A20SC0455, and Emerald Disha Alifia Wisaksono A20SC0467. Now before we start showing our experiment, we would like to begin with a little bit of introduction. Aspirin is a weak acid which contains a carboxylic group, an ester group, and a phenyl group. The aspirin dissolves partially in water to form an equilibrium mixture with the carboxylate and hydronium ions. When it further reacts with NaOH, the carboxylic group is fully deprotonated to form a carboxylate ion and water, which will cause a quick increase in pH. After that, more weak acid will dissociate to replace the conjugate base in order to establish the equilibrium, which we will see the pH increase slower. And the endpoint of the titration is determined when all aspirin molecules have dissociated and all the hydronium ions produced are neutralized by hydroxide ions, or when the hydroxide ions from strong base are no longer being neutralized, which we will see by a sharp increase in pH. So, our objective in carrying out this experiment is to find out whether the aspirin tablets that we can readily buy from the pharmacy contain the correct amount of active ingredient in aspirin, which will help us determine which brand has the best aspirin content. This is the list of apparatus that we use in our experiment: 100 ml beaker, burette, pipette, 250 ml volumetric flask, retort stand, pestle and mortar, 100 ml conical flask, white towel, dropper, and filter funnel. And for the materials that we use aspirin tablets, 0.1 molar NaOH solution, phenolphthalein, and distilled water. With all of these apparatus and materials, we conducted our experiment, which will be guided by Aisyah Mashure.
Now we are in part A to prepare for aspirin solution. First, add 10 tablets of aspirin into the mortar. Grind them into a fine powder. The aspirin powder has been transferred to a beaker and the mortar has been rinsed to ensure that none of the aspirin has been loose. Next, add water into beaker to dissolve it. Using filter funnel, transfer the solution into 250 ml volumetric flask. Rinse beaker, pour the content to the flask. Add distilled water up to calibrated mark of volumetric flask. Now, we have obtained a homogeneous solution.
For part B, we are preparing for the titration by set up the beaker and the burette. First, the pipette that has already been rinsed with water, now it needs to be rinsed with solution. Fill the pipette until roughly half full and rotate it to ensure that the inside is fully rinsed before emptying it into the waste beaker. Now, transfer 25 ml aspirin solution into the beaker by using volumetric pipette. So remember to line up the bottom of the meniscus with the mark. Now the setup for the beaker has been done. Next, we are preparing for the burette setup. Before we fill it with sodium hydroxide solution, we need to rinse it with water and some of sodium hydroxide solution. As a safety precaution, always make sure that the top of the burette is below eye level when you fill it. Rinse with water. Then, rinse the burette with some of the sodium hydroxide solution. Then, fill the burette with sodium hydroxide solution. Remember to close the tap when filling the burette. Remove the funnel afterwards to ensure the fill level remains constant. In part C, we are determining the indicator using pH probe. Use pH probe to obtain a plot of pH against volume added from the burette. The information can be used to choose which indicator to use in the titration. Run the titration well past the endpoint until the pH stops increasing to obtain a complete titration curve. Based on the graph, we can see that phenolphthalein and bromothymol blue can be used as indicator.
Next, we are going to do the titration part. First of all, let's fill in the initial burette reading, which is 10.00 cm cubic. After that, we can start titrating. We should do the titration until the endpoint, which is when the color of the titrant changes. And then we jot down the final reading, which is 28.05 cm cubic. After that, we have to find the volume of titra, which is we should subtract the final reading with initial reading. And we get 18.05 cm cubic for the trial titration. For the first titration, it's already given the initial and final reading, which is 8.15 and 26.95 cm cubic respectively. So, we just need to find the titra, which is 18.80 cm cubic. We need to conduct the second titration. So, let's begin. As we can see, the color of the titrant is changing, so we need to mark the final reading, which is 27.10 cm cubic. And the titra that we get is 18.65 cm cubic. As first and second titration have some difference, so it is not concordant. So we need to do the last titration. and the final reading is 28.25 centimeter cubic, while the titer that we get is 18.65 centimeter cubic. As second and third titration is the same volume of titer, so the results is concordant. So the mean is 18.65 centimeter cubic. The slides shown here are the results from the titration and also the graph of pH against the volume of sodium hydroxide. What we can see from the graph, the solution reached the equivalence point when 15 centimeter cubic of sodium hydroxide is added. For the discussion part, concentration of sodium hydroxide that we got from the experiment is 0.1 centimeter cubic, and the mean titer of sodium hydroxide solution is 18.65 centimeter cubic, as it's shown in the previous slide. So, what is the mole of sodium hydroxide? To calculate mole of sodium hydroxide, we need to use the formula mv over 1000. So, m is 0.1, v is 18.65, and divided all with 1000. So, the mole that we get is 0.00187 moles. What is the mole of aspirin? From the chemical equation, we recognize that the molar ratio of sodium hydroxide and aspirin is 1:1. So, the number of mole of the aspirin is the same as sodium hydroxide, which is 0.00187 mole. What is the mass of aspirin per tablet? To calculate mass of aspirin, we just need to use the formula mole equal to mass over molar mass. So by substituting mole and molar mass, we get the mass of aspirin, which is 0.337 gram. This slide shows the overall calculation that we had done in the previous slide. As the conclusion, the aspirin content in each aspirin tablet does not fall within the acceptable range as in the quality standards that shown in the first table.